In today's episode of Learning with Jason, I'm going to be exploring or explaining some stuff that I've learned about CNC milling, I think is the technical term. CNC milling. What's up YouTube, Jason here with Byte My Bits, and this is a learning process for me. If you guys did not catch the laser video that I made before, I basically got this little CNC machine that comes with a laser head and a milling head. So I was basically trying to make key tags. Now the whole key tag thing is really, it's just a pet project. It's like, want something to do with it, a goal to have type of deal. So it's not like a huge important thing, but I quickly realized that unless I was writing to something like a red, a black, or any kind of like a darker color, something that was easier for the laser to catch onto and burn off, that it was just extremely hard to get contrast. If you look at that, it just kind of barely shows up. Look at that. Do you see it? It's barely. Now, of course, a bunch of users were quick to point out that if you want to do something like what I was planning on doing with anodized aluminum key tags, that you need a CO2 laser. Those are usually 20 to 40 watts, something like that. Whereas this laser is only 7 watts. So, you know, I'm a little off base here. Now, because this is more of a curiosity pet project and I don't want to go out spending thousands of dollars on a laser that I'm just gonna make some key tags with because I'm curious, I instead decided to turn my focus to the milling machine, which, by the way, is a whole different world from lasering. It's got a whole nother axis. It goes up and down. Now the idea here was to basically have this spinning thing, which you can see right here in one of the bits that I've broken off. Yes, I said one of the bits, I've broken a few. I just want this to spin fast enough and just barely take off a hair. Now, as you can see, I've had a little bit of success and a little bit of failures. Anything from absolutely horrible to not bad. This one right here was actually one of my first attempts where I basically just taped it down and I tried to mill it and it started to break loose and it looked absolutely horrible. As you can tell, let's go back up. Okay. As you can tell, it did not come out looking great. After a few more attempts, I had this black one here, which the P came out looking perfect, but because I did not have the key tag straight on the board, it just kind of fell off. I also tried with some other bits, some different settings. I even accidentally drilled all the way through one, and I got a couple of these that, well, they just didn't turn out very good. And this is where really I come to the learning part of this entire experience, and I'll give you your first lesson. You don't need laser goggles. It's a mill. What you do need, however, are safety glasses, because when you are spinning something, however fast it spins, and you're, flinging metal throughout the air, you don't want it in your eye. Title your sex tape. But in all seriousness, let me give you a walkthrough of some of the things that I've learned throughout this process. It's very interesting, but there is definitely more learning to go, and I'm sure that some of the questions and things that I make in this video, someone's gonna have some recommendations. So let's jump right into it. Now this is something called GRBL control or candle. Basically it allows you to take a set of G-code instructions and transmit it over to your machine. Now the G-code is gonna look like something like this. As you can see here, I have a rotating speed of 1000, a something per millimeter per second speed of 20, which is relatively slow. And these are the G-code instructions needed in order to cut paint van. Now to create this, and I actually got on Twitter to ask some people, I needed to find a program that was super easy to just, put in some text. And that's where F-engrave 1.71 came into hand. It allowed me to create basically what I wanted, which was just a simple text. And you can take this and you can save it to a G-code. Now the G-code does not come out perfect, which was something that I learned, meaning that I had to go into an example that actually came with this program that had a few basic guidelines because I was getting error messages in my software. So I copied the header information and I ended up moving that to replace the header text that F-code gave me. I don't know exactly why the program didn't give the correct header, but Candle was throwing up an error anytime I tried to send it to the mill. Now, getting the instructions and the size and all that stuff, that's kind of difficult to master. But after a little bit of trial and error, as you probably see some of the stuff on this board here, I was kind of sort of able to get it to work. I turn on the control board and this thing should automatically connect without me having to do anything. Now I have yet to have a successful attempt at creating a constant good-looking key tag. Everything that I do comes out at least a little wrong, but this was probably one of the closer ones. I just messed up the P and then I tried some other settings and, you know, here we are. So to walk you through basically what you have to do to get it set up, once you have everything turned on, obviously it's not in the right position, so you have to kind of sort of calibrate it, or whatever the technical term is. And that's really just a matter of clicking these up and down arrows, positioning this thing, oh, wrong way. Positioning this thing over the key tag. And then we're gonna move it down. Now what I learned here with aluminum anodized key tags is that if you're trying to make something like this, for example, you need to get it as close as possible. Now that includes moving this tip as close as I possibly can to the key tag. Now I can tell that it touched it, right? Which I don't want to touch it, but I could tell that I touched it. So something I've been doing is pretty much loosening this up and getting it to touch, but just barely. And that's really something that I found here, is that just 0.01 millimeters is some of the things here. And it's like, it has to be really, really on point. So I'm going to take this and I'm going to drop it down to where it is just floating right over the top, just barely. And now that I have it floating just over the top, I'm going to set the 0Z, which is pretty much calibrating the 0 for where that tip is. Whereas this button right here zeroes out X and Y. So pretty much what I have to do is find the starting point and the end point to make sure everything fits. To set the X and Y, of course I'm going to move this tip up because it is technically as close as possible and thus might be touching the tag. And then I'm going to move this to find the starting point. So what I have to do is make sure that when the tip goes to the top of the P, which I always get my little directions here turned around, just got to make sure that it has enough rooms. So there you go. The top of the P is at the top of the keychain here. And then if I go down to the bottom here, equivalent to where the V is, that's at the bottom right there. So that tells me that that should be aligned pretty decent. And then if I go this way, the T looks like it is just barely going to be on the top of the key tag. I'm going to go here and just slightly adjust it. So there's the P. And the T. Now it's usually right about this point of the process where I get everything calibrated, set up the way that it should be, and I think I'm good to go. I think. Now in my settings file, I actually have it at a cut depth of 0.01 millimeters. So very, very shallow, like, you know, I don't know, however shallow a human hair is, but, you know, shallower. So I'm going to go ahead and raise the head on this. That way I can get started without scratching up the key tag. And if all goes well, this should print. Full send. Now basically I just vacuum all this stuff up, and then I use tape to kind of try to pull like anything that's left that can be easily pulled off. Not necessarily the best way, but I don't know, it's what I do. Now as you can see, this is the end result, and it's not as good as a previous attempt where you can see the P and the V turned out really, really well. I've been trying to recreate this P on everything else. Some of it did turn out okay, which is like the T, the top of the T there looked pretty good, some of the top of the I. Some of it did look pretty good, but the rest of it came out pretty rough. Now this really just comes down to it not being super flat, and maybe tightening down on each side makes it to where, you know, the top or the bottom are a little bit more secure than the middle of the keychain. But in some of my earlier trials, as you can see here, where this is super, super rough, I did not secure it down at all, aside with just some tape, and it came out looking extremely bad. Look at that. Like, that is just in no way usable. Whereas this, it is kind of rough, but you know, it is technically better than this, and you could probably still use this. But here's the trick: recreating the exact same thing, but on the opposite side. Even though it's not great, I'm still going to try to have it to where it's on both sides and looking decent. And there you have it. I tried to recreate this, and that looks good, decent. I mean, not great, but it's decent. And the second side came off just a little bit worse. Now, I don't really know why, except from when I did this side, obviously it roughed up and it wasn't as flat, so it was kind of an uneven surface, but you know, that's the end result. So what have I learned? Well, I learned that I like lasers a whole lot more than a milling machine. Getting everything lined up and calibrated and working perfectly with 3 axes, it shouldn't be too difficult, and I'm sure that there's something I'm doing wrong, but in the end of the day, it's like when you want to use a really fine tip spinning very fast and taking off a very thin layer of paint or anodization on aluminum, well, it's difficult. So to continue my little pet project of mine, I actually ended up ordering some different types of keychains, key tags, I guess. I mean, a wooden keychain is definitely not as cool as something like an aluminum keychain, but I do want to go back to playing with the laser, and if I have a wood key tag, technically I could burn something on a wood with the laser, but I just can't do it with aluminum. But when it comes to engraving or milling or whatever it's technically called, I found that the least amount of vibrations are the best, and that's the best result. Although I have yet to master that, but still I found that I get better results when you actually secure it down. The second thing is calibration on your Z-axis is really, really important, especially when you're doing very fine cuts, like taking off the paint off aluminum. Every time you finish something and you want to recreate it again, you always have to recalibrate. That's just, you have to. Well guys, that's it for today. I just wanted to share this journey of mine of trying to perfect the key tag and some very fine milling / engraving, whatever you want to call it technically. I have been working on this for an embarrassing amount of hours, and I had nothing to really show for it, but I did want to share the learning process and some of the things that I've come across while trying this out, and kind of throwing it out to the audience, anyone who has experience with this. Am I doing something wrong? If you have any tips for me or comments, all the things I did wrong, leave them in the comments down below. As always, thank you for watching, like and subscribe, and have yourself a great day.